Hey everyone, so I'm going to do a video on factor by grouping. I have the steps on here, so your first step will be to arrange the terms so that the first two terms have a common factor and the last two terms have a common factor. So looking at my first example, I'm going to look for if my first two terms have a common factor and if my last two terms have a common factor. Now, in my first two terms, they do have a common factor. They both have b squared. And in my last two terms, I'm able to pull out a factor of 2. So they do have that. So what I can move on to at this point is splitting the polynomial down the middle. It says for each pair of terms, use the distributive property to factor out the pair's greatest common factor. So the next thing would be pulling out a GCF out of both sides. So the GCF out of the first side would be b squared. When I pull out a b squared out of both pieces, I'll be left with a 4b because that will cancel out two b's on the top, be left with 1 on the top. And this would become 1 because something divided by itself is always 1. On the other side, the GCF is 2. So if I pull out a 2, a positive 2, I'd be left with 4b plus 1. Now, the next step, you should see a common binomial, and we do. It's right here. It's 4b plus 1. So I'm going to pull out that 4b plus 1. And while I do that, I'm going to divide each side by 4b plus 1, allowing the 4b plus 1s to cancel. Whatever's left over is going to be left in its own separate binomial expression. So this is your factor by grouping. Same idea with the next one. I'm going to check if there is common terms in the first and the second. And there is here, I see that I can take out a 4 and a k squared. And here I can take out a 5. So because there are things that are common, I can split this down the middle. I'm going to pull out a 4k squared in the beginning. So I want to divide each piece by 4k squared. Again, I pulled out 4k squared because in both terms, they both divide by 4. And this has 2k's, this has 3. So I can technically take out 2 from each of them. Alright, so I'll be left with 7k minus 1. Now, you need to realize that on the other side, I'm going to want to have 7k minus 1 somehow. And by looking at this, I do notice that I can pull out a GCF of 5. And when I pull out that GCF of 5, I'm left with a negative 7 plus 1. A negative 7k, I'm sorry, plus 1. But I want a positive 7k plus 1. So because I want that positive 7k, instead of pulling out a positive 5, I'm going to pull out a negative 5. What that will do is make this become a positive 7 and make this a negative 1. So there you go. I got my 7k minus 1. So now that I have my binomial GCF, I'm going to pull out that 7k minus 1 out of both terms and write it on the outside. And then whatever is left over, which is the 4k squared minus 5, will be written in its own binomial. Alright, so that's that. The next one is also factor by grouping. And again, I want to state that factor by grouping is pretty obvious to notice that you need to do it because it has 4 terms. Actually, any even amount of terms could be applied to factor by grouping as long as there are common GCFs out of the pairings. Now, looking at this one, if I look at my first two pairs, I do not see a common GCF. Like, there's nothing I can pull out of both of them. So what I'm going to do with this problem is I'm going to rearrange it. And I'm going to rearrange it so that I have like n's and x's together. So what I'm going to do is switch these two. So I have 7xy minus x minus 3n plus 21ny. Okay. Now, I think I'm even going to switch things further because if you notice over here, this has a positive and a negative, and then this has a negative and a positive. So I might want to switch these so that I have a easier factoring down the line. So I'm going to switch these two now so that I don't have to worry about any negatives. Alright, so basically you can move around the polynomial as much as you want. It's really okay as long as you keep the signs. So I'm going to split this down the middle on the first side, I should be able to pull out an x. So the x gets pulled out. This goes away. You're left with 7y. And then this pulls out with a -1. Now on the next side, I notice that there is an n in both of them. And also I have the number 3. And 3 goes into 21 7 times. So I'm able to pull out a positive 3n. And what's actually pretty cool is that because I pull out that positive 3n, this cancels to 7, the n's cancel to get you that 7y, and then these cancel and these cancel to get that -1. And actually it's kind of nice because that double switching that I did really worked out for me. So now I can see that these are my GCF binomials, and I'm going to pull out that 7y minus 1, divide each piece 7y minus 1, and I'm left with that x plus 3n. And there you go. Hope this video helped on you factor by grouping. I'll see you guys soon.